Hello, this is Chuck Ridgway, Automation Technology Manager here at Horner. We thank you once again for joining us for another Tuesday live stream. Today we're going to cover an instruction, I guess it's more than one instruction, but a couple of instructions that can be a little bit intimidating for those who are new to programming. For those with a computer background, not so much, but for those who are new to ladder logic programming or programming in general, it can be a little intimidating. What I'm talking about today are shift register functions. But don't be intimidated because they can be pretty darn useful. Hello, this is Chuck Ridgway, Automation Technology Manager here at Horner. Thanks for joining us on another Tuesday live stream. Now today's topic is one that can be a little intimidating for new programmers or those who aren't familiar with ladder logic or computer programming in general, and that is shift registers. So today it's all about using shift register functions in Cscape. But don't be intimidated. Shift registers can be pretty useful. So I'm going to go ahead and bring in my colleague, Mr. Casey Gardner. How are we doing today, Casey?
Hey, not too bad. How's it going, Chuck?
It's going great. You know, as I just mentioned, for some folks, maybe it's because of the number of setup parameters required for the shift register instructions, or maybe because they really don't understand how they can be useful or how they should be used. Again, they can be a little intimidating, but I think you know, as I do, that shift registers can be pretty useful. Why don't you give us a couple of examples of that?
Yeah, I think the most common example that I've used them for are really just taking active either production data or just data you've collected in the application and being able to show it in like a trend object over time, either both shift or rotate functions, and just being able to use those and correlate them with a graph I find kind of really helpful. So that's just one way I've used them here recently. Yeah,
and certainly moving data and storing data are what using shift registers and rotate instructions are all about. You were talking about kind of some longer term data, right? And some graphing. Another thing people should keep in mind is you can also use that for some short-term stuff as well. So maybe you've got a short-term event where you want to capture data every scan for a few seconds. Shift registers are terrific for that. Okay, so while I'm covering the material today, Casey will be answering any questions you have in the chat. If you're watching this on replay, ask your question, just do it in the comment section, and we'll make sure that we answer it in a prompt fashion. Okay, let's go ahead and get started. Okay, so here's our program for today. Again, using shift register functions in Cscape. So we're going to, of course, define what is a shift register, kind of in the traditional sense of the word, and then we're going to review those shift register functions in Cscape, specifically the multi-shift instruction and the rotate instruction. We're going to talk about applications, where you can use them, where they're useful. We're also going to demonstrate a couple of those for you as well, as we always try and do on our Tuesday live streams. Okay, let's get started with what is a shift register? So for those of you with an electronics background or an engineering background on the hardware side, you may think of a shift register from a digital circuits perspective. So for those of you with that sort of background, you kind of understand that a flip-flop is a device that's used to store a digital value, a binary value of 0 or a 1. And then if you cascade a series of flip-flops in a chain, connecting the output of one to the input of the next one in the chain, you have now basically created a shift register, provided that they're all controlled by the same clock signal, if you will. And shift registers, what they allow you to do is they allow data to be shifted to the left and data to be shifted to the right. Well, how useful is that really? Well, they have a couple main functions when we're talking about using them in a control application. They are very often used for data storage and also for the movement of data. Again, if we take a look back at the digital circuits, when we're talking shift registers with digital circuits, we're strictly talking about binary data, strictly Boolean. However, with the instructions in Cscape that have to do with shift registers, for instance, the multi-shift function, it can be used with a whole variety of different data types, not just bit types, but also byte, word, and double word. So they can be really useful, again, when it comes to storing data as well as moving data. Okay, so let's take a deeper dive into the multi-shift instruction that's available from your moves list. there are a number of parameters that need to be configured. All right, and let's go over those today. First, let's take a look at the source. What is the source for a multi-shift instruction? Well, the source is effectively the variable array that contains the data that you're managing. Okay? So if you're talking about register-based ladder, you're going to be talking about a series of sequential registers or sequential bits. So it could be R1 through R500, T1 through T256. However, if you're talking about variable-based ladder, there is where you're really talking about variable arrays. So you create a variable, whether it's bit type, whether it's integer type, real type, whatever the proper type may be for your application, and then you assign it a dimension equal to the number of bits or words or floating point values that you want to manipulate in your shift register. Now, the length parameter in the multi-shift instruction, that's how many of those bits, words, double words that are going to be contained in your shift register. The n parameter is how many positions are we going to shift every time that we execute this instruction. Now, for most applications, you're going to shift one at a time. So every time you execute the instruction, you're going to shift by one. That's not universally the case. Sometimes you'll need to shift multiple positions with one execution, and occasionally the number of positions you shift will be variable, so you might want to assign a variable to that particular parameter. The direction field or parameter basically determines which direction you shift. Are you going to be shifting the data to the left or to the right? Now, when we say left and right, that's where people can get confused, and it's understandable. So the way I like to illustrate it is like this. Think of kind of the binary representation of a word value. When you shift left, you're shifting from lower significance to higher significance, or least significant bits up to a higher significant location. When you shift right, you're doing the opposite. You're shifting from a more significant location to a less significant location. So when you think of left and right in regards to the shift instructions, think in terms of those parameters, okay? Now the in parameter, that's the data you're going to shift in to your shift register, all right? The out parameter is the data you're going to shift out of your shift register. Every time you execute this instruction, you're going to be shifting data in, and every time you're going to be shifting data out. The variation is going to come depending on which direction you're shifting, and we'll cover that later on today. Okay, let's take a look at our first example of a multi-shift instruction, all right? So in this case, we have assigned a source to a variable array called widget storage, and it happens to be a variable array with a dimension of 8. So that means there are 8 bits in this case, because we've assigned bit type to this instruction. We have 8 bits, and they're all stored in the variable array widget storage from 0 to 7. Again, length of 8, we're going to shift by one position every time we execute the multi-shift instruction. The direction we're going to shift, I have assigned an always on contact to the direction input, which means we're going to be shifting to the left, or from a position of lower significance to a position of higher significance. All right? And then the input, we're shifting in from a widget sensor. Could be a photo eye or something like that that's detecting whether there's a widget present or not. And then their output, in other words, what we shift out from our shift register position, is a variable called widget output. Okay, in the center bottom there, you see in the blue boxes, those are the current states of the data within widget storage. And I have happened to have drawn it from least significant, or the first element in the array, 0, is shown on the right. The last element in the array of 7 is shown on the left. My input, I've drawn that on the right. Widget sensor, my output, widget output, I've drawn that on the left. Okay, so this is the initial state of my shift register. Okay, now let's go ahead and do a shift where we go ahead and shift left. All right, so if we shift left, remember what that means. is the input gets moved to the first element, in this case, element 0. The last element, which is element 7, it gets shifted to the output. All right, and then all other positions move from lower significance to higher significance. All right, so that's the result of our shift left. So we executed this instruction one time, and that's the result with the shift left. Now let's take a look at, we'll go back to our initial state here of the same data we started with, but this time we're going to shift it right. And to shift it right, we need to assign a 0 to our direction variable. I'm not showing it in the upper right-hand corner snapshot, but effectively we would, for instance, be assigning always off instead for our direction. And then in this case, what happens is our input doesn't go to the first element. Our input goes to the very last element. You can see the line I've drawn there at the bottom of the screen, going from the input all the way over to element 7. And then in this case, the element that is getting shifted out is actually element 0, because everything is shifting right. And that means element 0 has fallen off the pile, if you will, and it ends up in the output. All right, so this is our first multi-shift example. It was a binary example. We showed first shifting left, then shifting right. However, one of the great things about multi-shift is that it's not just useful for binary data. It's also really useful for integer data, for floating point data, whatever the case may be. So here's our second example where we've assigned another multi-shift function. This time, our data type happens to be word data type. In this case, we're talking integers, all right? So our source is another variable array called test_sample. It also happens to have 8 elements in it because it's easy to show on the screen. If you get more than 8, I can't really draw diagrams very easily. Again, we're going to shift by 1, which is what we do most of the time. And then we're going to start out by shifting to the left, which is the most common direction you would normally shift. And then the data we're shifting in is a variable called process temp. And then our output that we're shifting out is just a variable called test sample. It's actually the same variable we're using to store all of our data. We just, instead of having a variable array of a total of 8 elements, I went ahead and tacked a 9th element on there. And then I'm just using that 9th element for the output. Okay, not something you have to do, but in some applications, the output of a shift register is very important. It's really what you're after. In other applications, the output of the shift register is data we've already used. We don't care about it anymore. We're just discarding it. So that's one thing you'll find with shift registers. The usefulness of the output register, if you will, is going to vary based on your application. Okay, so this is what we're looking at here for our initial state. Let's go ahead and shift that left and take a look at what that means. Okay, again, when we shift left, we need to make sure our direction input is on. We're going to take our input value, move it into the very first element, in this case element 0, and then we're going to take the last element, in this case element 7, and move it to the output side of things, and then everything else shifts. All right, as you can see there, based on the direction of those arrows. Now, I drew this top to bottom this time instead of drawing it right to left, but hopefully you get the idea here. All right, now let's go back to, again, looking at our data as it started. Now let's shift it the opposite direction. And again, same thing happens as when we have binary data. Our input value goes to the last element. The first element falls off the end of the shift register and gets copied over to the output. Okay, so hopefully that is becoming a little more straightforward as you look at how we manipulate the data. All right, now all these diagrams and theoretical discussions on what parameter goes where is useful, but let's start talking about some actual applications and where we could actually use this information. So let's do an example application here. Let's talk about a use case where we're going to configure an OCS to record pressure readings from a sensor at the fastest possible speed and then graph those results on the screen. So keep in mind that the OCS has data logging capability built in. And it's actually very functional, and it can perform quite well. However, the absolute fastest you can run data logging is every other scan. All right. So in this scenario, we want to go as fast as possible, taking as many samples as possible. So by using a multi-shift instruction, I can build a ladder routine, which effectively is going to allow me to record data every single scan for a certain number of scans. And then at the end, I want to take that information and display it on the screen. Okay, so the procedure we're going to follow here with our ladder routine. First thing that we're going to need to do is we're going to want to put a push button on the touchscreen that'll allow us to kick off the test. We're going to want to, as we initiate the test, we want the ladder logic to clear out any old test data, reset sample counter, because keep in mind when you are recording this information scan to scan to scan, it's usually best if you shift a set number of times. Then it's much easier to do with the data later if you know how big the data array is or how many times you've shifted. So what we're going to do is we're going to go ahead and record a fixed number of samples. And to do that, we're going to use a sample counter. And so as we initiate this process, we want to clear out that sample counter, clear it back to 0. Now, after that's cleared out, and as we start recording samples by shifting in the pressure value into our shift register every single scan, we're effectively going to count up to a certain number of samples, let's say 750 in our case. So for 750 consecutive scans, we're going to record the pressure value. Scan time's probably in the 4 to 5 millisecond range. So, it's going to take a few seconds, and then we're going to have the data we're looking for. And then we're going to want to take that data and put it in an XY graph instruction so we can view it on the screen. So that's our process. Now, one of the things that's often difficult to deal with, or at least to get your head wrapped around, is what direction do I want to shift when I actually am storing away my data? So let's think through that for a minute before we actually go in and start setting up our ladder logic. Okay, so first of all, if we're shifting left, all right, where the direction input is on, or a 1, what's going to happen is we're going to take our input value, the value that, it's our pressure in this case, and we're going to put it in the first variable position, all right? And then every subsequent time that we shift in additional data, it's going to move lower and lower and lower, or further away from the beginning of the data. So at the very end, the first piece of data that we log is actually going to be in the last position of our variable storage array, which is obviously not what we want. Now, if we shift the other direction, or shift right, so our direction input is 0 or off, we're going to take our input, or our pressure value, we're going to place it in the last position in the array, and then it's going to shift closer and closer to the beginning as we shift in more data. When we've shifted in our very last time, then the very first sample we took is going to be at the very beginning of the array data. So that's ultimately what we want, okay? So the test data will end up in the desired order. So in our example here, because of the way we're storing the data and the way we want it to look like as we use the data later, we're actually going to make sure our direction is to the right or off. Okay. All right, let's go ahead and take a look at how we might configure this or program this in Cscape. All right, so I'm going to go ahead and fire up Cscape here. All right, so let's go up, and I'm actually going to scroll up to the beginning of this logic. So we're going to get started with a push button on the touchscreen. We'll go ahead and kick things off. Now I've configured it to trigger a one-shot or a positive transition coil. Why do I want to do that? Well, that's because I have a few things I want to do at the very beginning of the test, and then I don't want to execute those things anymore. What are the things that I want to do at the beginning of the test just one time? Well, what I want to do is I want to clear out or reset my sample counter. In this example, I'm going to be shifting my shift register 750 times on 750 consecutive scans to record 750 pressure values. All right. So since I'm going to be counting those samples, I need to reset that counter to 0. And then I'm also going to fill my test array of 750 words all with a value of 0. So this particular instruction will write a 0 to every member of the test sample array, starting from 0 and ending up at index 749. When I'm done with that, I'm also going to want to make sure I clear my test complete flag, which may have been set from previous tests. All right, so all that I want to execute just one time. Next, this is a step that I'm taking in my case that normally you wouldn't take in your application, but in my case, I want to delay the start of the test for a couple of seconds so that I have time to, manipulate the pot that's going to actually cause some data to show up in our demo. So to do this, what I've done is I'm triggering a 2-second timer with that same one shot, but that one shot is going to turn off. So I've got to keep this timer timing. And to do that, I'm actually using the timer active flag, which is the 15th bit of the flag register for the timer. I'm going to use that to seal around the init bit. Once the 2-second delay has occurred, I'm going to go ahead and set another flag that basically says, okay, let's go ahead and run our test. And this bit is going to turn on and it's going to stay on for the duration of the test. All right, now let's scroll down and let's take a look at the rest of our data here. Okay, so this is our test run bit that's going to stay on for the duration of the test. Every time we execute this rung, we're going to add 1 to the sample count. So it's starting at 0. The first sample is going to be 1 because we're adding a 1 to it. And then we're going to go ahead and execute our multi-shift. Let's double click here and take a look at the specifics of how we configured it. Again, here's our array. In this case, it's a variable array called test_sample. It happens to have 750 members in the array. We're going to go ahead and allocate those 750 members here. Every time we execute the instruction, we're going to shift by 1. We're going to go right. Remember, we talked about we want our first sample that we record to end up getting all the way back to the front. And the only way to do that is to actually shift right so that our input gets stuck to the end of the array and then it shifts towards the front. All right. The input that we're going to be recording, or basically shifting into the shift register, is called test_pressure. And then if anything falls out of the array, it's going to be copied to multi-shift out. Now, in this particular case, I don't believe that, well, I guess technically we will have some things falling out of the shift register. Every time we shift it, we'll have a value that falls out. But in this case, because we're clearing all the values to 0 at the beginning, the only thing that gets shifted out every time we shift is going to be a bunch of zeros from when we cleared the array to begin with. Okay, so that's the details of our multi-shift function for this particular application. All right, so after we execute this the first time, we now have our input stored at the end of the array, and then we're going to continue to execute this on 750 consecutive scans until the point that our sample count is equal to 750. At that point, our test is complete, and we can turn off our test run indicator. All right, so that's the logic that's involved in sampling 750 times as fast as we can a pressure value. All right, let's take a look at what things look like on the screen. All right, actually, let's just go straight to the OCS and take a look at what that looks like, and from there you can also see the, well, no, let's here I am, changed my mind 6 times again. All right, let's take a look at the Cscape graphics that I've configured for this particular case here. Okay, so here's my start button that I've configured. I've got a running indicator that's going to turn on when the test is in progress. For convenience, I went ahead and allocated or put on the screen an indicator that shows the current pressure. And then, of course, I have a jump button to get me back home as I need to. And then this is an XY graph. Okay, so I'm going to go ahead and double click here and show you how that's configured. So with an XY graph, it's really not really an XY graph because you're really just looking at a series of consecutive values, which is what we want to do here. But the first thing you have to configure with an XY graph is a trigger bit. When this bit turns on, that's when the graph is actually going to go ahead and display the data, because it doesn't do so unless you turn the trigger bit on. Okay? Now, other than that, the only thing to configure is how many values you want to plot. In this case, it's 750. That lines up nicely with my array. And then the only other thing to configure really is the data that you want to graph. And you do that from the pens option here. All right. And this is where we plug in our variable, the start of our variable array, which is test underscore sample. And the first member of that array is index 0. All right. We are going to graph, if you will, all 750 members of test underscore sample, starting at 0, ending at 749. And that's going to happen whenever the test complete bit turns on in our ladder logic. And remember, the test complete bit turned on at the end of the logic that we wrote to capture the data over 750 consecutive scans. All right, so that's what it looks like on the screen. Let's go ahead and take a look at the OCS in real time. All right, so here we are on the main screen. Let's go ahead and go to our high-speed test section here. Okay, I'm going to go ahead and get ready to initiate the test here. All right, let's go ahead and, looks like I have a problem here with my, oh, there we go. The data is happening. All right. All right, so there's a look at our test. All right, you can see our value started out low. It dove to minimum and then started coming up again. Let's see if we can do a little better job on our next capture. All right. There we're looking at some high-speed data. All right, there we ended up with the pressure going up to maximum and going down again. So basically what's happening when I press this button here, after 2 seconds, our sampling starts happening, and then we're taking samples until we reach 750, and then when that's done, we go ahead and display it on the screen. Okay, so that's kind of a look at the logic that we wrote to use a shift register to record 750 samples of data as fast as we could, and then just a quick look at the XY graph object on the OCS graphic screen that was used to kind of show that data graphically again on the screen. Let's go ahead and continue on with our material now. And let's jump into another instruction that's related to the multi-shift instruction, and that is the rotate instruction. So this is very, very similar to the multi-shift. It's just a little bit simpler, actually. All right. So if we take a look at the rotate instruction, in this case, we are rotating data in a circular fashion. In other words, we aren't really shifting data out anywhere. We're just shifting data around, if you will. Okay, but let's take a look at this instruction. Specifically, let's take a look at the parameters. Source, the same as multi-shift. It's the variable array containing the data that you're going to be rotating or shifting. Length is the number of elements in the array. N is how many positions we're going to rotate every time we execute the instruction. And direction is the direction we're going to rotate. Again, if that input is on, we're going to rotate left. If that input is off, we're going to rotate right. Okay? You'll notice it doesn't have an input or an output, and that's because you're not shifting data in and you're not shifting data out. You're shifting data in a circular fashion. So let's take a look at an example here. Okay, so a very similar diagram as to what I showed with the multi-shift example, at least the first one. All right, we've got a rotate instruction set up for bit type with a source of a variable array called machine underscore position. It has a length of 8, so it's a array with a dimension of 8. We're going to shift by 1 position every time, or rotate by 1 position every time. And the direction we rotate is again going to be dependent on the direction input. If it's on, we're going to shift left, or rotate left if you will. If it's off, we're going to rotate the other direction. Okay, so here's our initial data. You can see the 8 data elements of the machine position binary array. So here we shifted left. Very simple. As we shift left, everything goes to the left position, goes to the next position left from where they are. Again, thinking of the data as a kind of least significant to more significant type direction. And then, of course, that last element doesn't have anywhere to go. So in the case of the rotate instruction, it rotates back around to the first element. Okay, so if we're going to rotate left, everything shifts left, the last element rotates around to the first element. Pretty straightforward, a little easier to deal with probably mentally than the shift register to a certain extent. Again, let's go back and take a look at that initial state. This time let's shift the other direction, where we shift right, making sure our direction input happens to be off. All right, when we do that, everything shifts right from more significant to less significant, and then that bottom or first element, if you will, doesn't have anywhere to go, so it rotates back around to the last element. Okay, so the rotate instruction is very similar to multi-shift, but it's a little simpler to deal with. Next, let's go ahead and talk about applications for rotate. And there are certainly plenty of applications for this instruction as well. And in this case, let's go ahead and do an example where we're illustrating data movement. So this example is not going to be all about storing data. This example is going to all be about representing data movement as parts move from station to station, or as a machine rotates, or as a machine moves. Okay? So in this use case, we're going to configure an OCS to display the status of the parts on a piece of rotary equipment. So in this example, what we're going to do is we're going to create a variable array that represents whether there's a part present or not on each station of a rotary machine. And in our example rotary machine, there's going to be 8 stations. Now we're also going to create variable arrays for push buttons that we can put on the screen to either load a part or to clear a part from the particular station, or from each particular station, if you will. And then we're also going to create push buttons that will allow us to move the entire machine, or index the machine, or rotate the machine either clockwise or counterclockwise. Keep in mind we're kind of in a rotate or circular type rotation here, so it makes sense to think of things in terms of clockwise and counterclockwise. All right? And then we're also going to create a user screen to show the status of the machine, and also to allow us to load and clear and rotate and those sorts of things. Okay, so that's really what we're going to be doing in this rotate example. Okay, so let's head back to Cscape, and let's change from our shift routine over to our rotate machine, and let's take a look at what we're doing here. Okay? All right, well, let's do this. Let's actually start on the touchscreen, because I think if we graphically can see what's going on, it will be more clear to see what was required from a logic standpoint. Okay, so here's a graphical representation of our rotary machine, and each of these indicators here indicates a position on the machine. So if this position is red, all right, then it's going to indicate there's no part present on that station or that particular location on the machine. If it's green, it means we've got a part that's present. If we want to load a part onto the station, we hit the load button. If we want to clear or remove the part from that station, we hit the clear button. And of course, every location on the machine has a load button and a clear button. And then to rotate everything, we've got a clockwise rotation button and a counterclockwise rotation button. Okay, so you can see that's what we're going to be looking at here. We want to see the status of the current machine. We want the ability to load parts or clear parts. We want the ability to rotate either direction when we rotate the entire machine. All right, now let's go back to logic and see some of the supporting logic behind these graphics. Here is the rotate clockwise push button and the rotate counterclockwise push button that we have on our touchscreen. When we press the rotate clockwise push button, we're going to set, we want the direction to be clockwise. All right, and if we look down here at our rotate instruction, we can see that the direction input to our rotate instruction is this bit that we're looking at here, the rotate direction clockwise bit. So if we hit the clockwise bit, we're going to effectively shift left, which is going to cause, graphically at least on the screen, things to move in a clockwise direction. If we press the rotate counterclockwise push button, we clear that bit, setting a 0 into our rotate instruction. Okay, now regardless of which of these two buttons we press, we want to make sure that we rotate one position, either clockwise or counterclockwise. So to do this, we are using a positive transition one-shot coil. All right. Why a one-shot coil? Well, we only want to rotate one position. So therefore, the one-shot works great for that. Okay. This is not the shift register, the multi-shift instruction and the rotate instructions. Those are not transitional type instructions. They will execute as long as they have power flow. So one-shots are very useful if you want them to execute exactly one time. Okay, now finishing up the setup for our rotate instruction. Again, there's our variable array called machine_position, which has 8 positions. So it's an array from index 0 to index 7. We're going to shift exactly one time every time we execute our instruction. And there's that direction bit that we talked about a little bit before. Okay, and then down here at the bottom, we just have some very simple logic, which basically takes the load push buttons that we press on the screen and loads the appropriate bit or the appropriate status on the machine. And then we have the same thing for clear. All right, let's go ahead and take a look now at the OCS. Let's leave our high-speed data screen here. Go to rotary machine. All right. And then let's go ahead and take a look at what we have here. So right now we have a machine that's completely empty. Let's go ahead and load parts up in a couple positions. So now you can see we've got parts, at least on 2 of the positions. Let's go ahead and rotate the machine clockwise. And you can see that the data, what effectively is happening is that we're executing that rotate instruction every time that we hit that, either the clockwise button or the counterclockwise button. Okay, so we cleared that data there, and now we're rotating in a counterclockwise fashion. Okay, so hopefully that gives you just kind of a quick look at how the rotate instruction can be pretty handy for doing things like representing the status of a rotary type piece of equipment, for instance. I believe that's pretty much what I wanted to cover from a material standpoint. Okay, I'm bringing Casey Gardner back in. So those are a couple of examples of using the multi-shift instruction as well as the rotate instruction. Hopefully that'll help people understand their usefulness and how to use them. I think sometimes one of the harder things to get your head wrapped around is what direction the data is shifting. Is it shifting left or right or up or down? But that can be something you can look up in the help file, right?
Yeah, absolutely. And one little shortcut that a lot of people don't necessarily realize is if you're working with a function you don't necessarily know much about or looking for more information on, you can double click, say, a function block after you place it down, and then hit F1, and it'll actually take you kind of a section in the help file that'll give you a lot more detail on just going over that function in general to a lot more detail, for sure. Pretty useful.
Absolutely, especially for the shift register function. The detail is which direction is left and right, where the data is going, all that kind of good stuff. Okay, so did we have any live questions for the presentation today?
I don't think so. I think you taught it too well, so that's all good.
All right, very good. Thanks, Casey. All right, so I want to remind you again, every Tuesday at 2 o'clock, we've got another technical topic we'll be covering in our Tuesday live stream. The September schedule, you can see it here. Upcoming still is analog I/O scaling as well as the compare functions. Again, next week, Tuesday, 2 o'clock, analog I/O scaling in Cscape. So don't forget, subscribe to our channel, hit that bell so you can be notified whenever we have new content on our YouTube channel. You can watch it, of course, on replay, which is really useful, whether it's on the YouTube channel or on our website. Once again, looking forward to seeing several of you next week for our next Tuesday live stream. Take care.